Nowadays, our Earth become hot, increasing of temperature, increasing of sea levels, and the melting of the ice cap. Do you know why? This is because the increasing release amount of carbon dioxide in atmosphere that produced from the burning of fossil fuels, exhaust from factories and vehicles, and deforestation has led to the greenhouse effect. So, I will take part to save the earth. My name is Atikah Binti Azali, had conducted a final year project entitled Comparing Ozone Production from Water-Cooled Dielectric Barrier Discharge in Carbon Dioxide CO2 and Air at flow rate of 2 liters per minute. Dielectric barrier discharge or DBD is a plasma technology used as an alternative for dissociation of CO2. Ozone is one of the end products for the reaction during the decomposition of CO2 as well as in air, hence it is used as an indicator. Besides, ozone also useful for sterilization application. Objective to conduct this project are to determine the electrical characteristic of the electric barrier discharge in CO2 and air, to measure ozone production under 50% duty cycle from CO2 and air discharge, to determine the reactive species generated in CO2 and air discharge. So, what is 50% duty cycle? The 50% duty cycles means that the signal will be on for 50% and off for 50% of the cycle. Duty cycle of 50% was selected to avoid excessive heating and to operate within the measurable scale of the ozone monitor. DBD is non-thermal plasma and are identified by the presence of at least one insulating layer between the cylindrical electrodes connected to an AC power supply as the dielectric discharge. CO2 and air were treated in DBD at ambient temperature. The inner electrode made of stainless steel rod while the outer electrode cylindrical is made of thin annealed copper wire mesh. The high voltage generator with 20 kV power supply of 300 watt at frequency about 20 kHz at 50% duty cycle was used to power the discharge. The PVC pipe water shower is made with multiple holes to allow the water to flow through for cooling system. It is to ensure that temperature is maintained during the high frequency dielectric heating. Next, the ozone is increasingly produced as the average power increase for CO2. While for LVD, ozone level reached the highest at 587 parts per million, recorded at 37 watt. As the applied voltage was increased gradually from zero, the current spikes appeared when the discharge ignites. At higher applied voltage, the current spikes grew in height and number. Discharge is sustained in filamentary mode. Comparing with the results of CO2 DBD, the drop in ozone formation at the higher applied voltage is most likely due to the increase of temperature and more rapid consumption of oxygen molecules to form nitrous oxide, especially in the air-fed DBD. Moving on, for the optical emission, it was determined by the peaks formed at different wavelengths. The activated species observed from the CO2 discharge in a water-cooled DBD are CO, CH, O2, CO2, and O atom. From this emission spectrum, it is shown that the decomposition of CO2 in DBD will release CO and O atom. While for air DBD, the activated species determined was predominantly nitrogen and two molecular bands. Overall, when the voltage increased, the current also increased linearly for both CO2 and air DBD. The temperature is fluctuated, but in general, it shows a downward trend as the voltage is reduced. The cooling of ozone generation by water-cooled DBD is necessary since the rise of temperature inside the quartz tube due to the high-frequency dielectric heating may cause the disruption of ozone reactions. In conclusion, major differences observed were at the ozone level concentration. Ozone production was the highest in air, about 4 times higher compared to CO2. This is because ozone conversion from the available oxygen molecules in air is easier and requires less energy than that in CO2, which required the extra process of breaking the CO2 to produce oxygen for the subsequent formation of ozone, O3. So that's all for my project. Thank you.